equipment speed makes it easier. I'm moving right along into purifying matter using separating techniques, or just separating mixtures. So you're going to try to purify this matter using special separating techniques. And if you remember our last video, before the Quizlet, I would have said that there are a lot of mixtures that exist, but because of their nature, they can't be separated the same way. For instance, separating sand from water, the technique you would use to separate the sand from the water wouldn't be the same technique you would use to separate salt from water, because of the nature of the mixture. So let's start with filtration. Filtration separates undissolved solids from a solution or liquid. The solution passing through the filter paper is called the filtrate, and the solid remaining on the filter paper is called the residue, as you can see here. This is a picture of the filtration process, and this is where we would have had the mixture. And in this case, you have just imagine you have salt and water, and again, you use filtration whenever you have a liquid and a solid that has not dissolved in the liquid. So to separate the two, use something like paper, filter paper, to form a barrier between the solid and the liquid. The filter paper will block the solids from passing through it, and the liquid will be able to pass through the small pores of the paper, and the liquid that is collected in the collecting vessel is referred to as the filtrate. Then we have the simple distillation technique. Simple distillation is used to separate a liquid from a solid. So distillation involves the process of boiling and condensation. It works because the components to be separated have very different boiling points. In this case, if you use salty water, salt, you cannot see it, but if you were to put your finger in there and taste, you taste the salt in there. However, you cannot use filtration to separate the salt from the water, because the salt molecule, the salt ions, or formula unit would have, a salt compound would have broken into its ionic form, the ions floating around in solution. And so all of this would pass through the filter paper because ions are very small. However, to get back that solid component that you had before, you will put it inside of this contraption here called simple distillation contraption. And so because the boiling point of salt is far from the boiling point of water, pure water, you'll be able to separate that water from the salt. So the water, being at a boiling point of 100 degrees Celsius, would evaporate and then come through this condenser and condense. That's what the condenser does. Cold water is passed through it to cause to cool down the vapors and cause them to condense, and then they will pass off into the receiving flask here, and this will be called the distillate, right? The salt though would not melt, because the flame from a Bunsen burner would only go up to 100 degrees Celsius basically, and the boiling point or the melting point of salt is 1,000 degrees plus. So the boiling points then should be very far apart. Coming up to fractional distillation, in this case the components in the raw bottom flask here, the components that make up the liquid solution, the mixture, would have closer boiling points, as we'll see. So fractional distillation is used to separate two or more liquids with different boiling points from each other, which are very close to each other. This method is used to separate petroleum fractions and to purify alcohol from a mixture of water and alcohol. So in this case, you would have as I said, the boiling points are closer, so you would use fractional distillation. And fractional distillation uses two columns. You have the fractionating column right here with some beads to help in the purification process, and then you have another column here where you would run the cool water through it. This is the condenser. Okay? And so, if you're separating the water from alcohol, please note that alcohol has a boiling point of 78 degrees around it. Right? Around there, an average of 78 degrees, while water has a boiling point of 100 degrees. And so this is where you need a fractionating column so that it would stop vapors, unwanted vapors from going up it. So your first fraction will be as pure as possible. This increases the chances of having a higher purity for your fractions that are coming off over here. So the fractional distillation on an industrial scale. So here again we're dealing with this is the main, so the crude oil, and the crude oil can be heated up into different fractions, and these fractions, the higher up you are, the lighter the molecules are for that gas, and the lower the boiling point. So small molecules have a low boiling point, they're very volatile, flows easily, ignites easily. Anything that's down here are larger molecules that would have a higher boiling point, and they're not very volatile, does not flow easily. So this is our industrial scale fractional distillation. This is how it looks. Now you know how many things you can get off of crude oil. Crystallization. So first we start off with the impure solid, which is dissolved inside of some type of solvent. You evaporate it using an evaporation dish, and the solution is heated to evaporate most of the solvent off to turn the process to evaporation to dryness, and then you continue heating until the salt is obtained. Once that is done, you put some heat on it. You heat it up, okay? You let it sit for a while, let it cool until crystals appear. And you could do this with common table salt, by the way. You just put in a lot of salt and water and let it sit for about 3 days, and you can start to see the formation of some huge crystals. That is NaCl. It's really cool, so you should try it. I think I should try it too, but I've done it already in the lab. As a matter of fact, you could use a piece of card, a piece of like card. You mix a lot of salt in the water and put this card, like, let's say, don't use plastic card. You need like soft cotton like card so that you could absorb the salty solution, and you're going to realize that you're going to see a line of crystals going up on that card. And then eventually when you're done, you just pour it over onto a filter paper and you let them dry. So that's a form of purification. It's a purification process as well, which is crystallization. Now we have paper chromatography. Paper chromatography is used to separate a mixture of different dissolved substances. And you usually use this with pigments like inks. Use it with chlorophyll too, to see what colors are in chlorophyll. And the method is often used to separate, as I said, the pigments present in food, colorings, and inks. It's a cool lab. You could even use it with your pen. Like this is a green pen, a green ink pen. But green ink is not just green ink. There are other types of colors that should be in here, probably pink, something, you never know. And every industry mixes their inks differently. With you get a better result with simple chromatography using black ink, because black ink uses nearly all the inks. Please note that you will have a baseline, and you place the ink dot right there, and the ink will go against gravity, raising up. And here's a little bit more explanation for paper chromatography. Each substance can be recognized by a value known as an RF value, which is a constant for a given type of chromatography paper and a given solvent system. The RF, or retention factor values, give the ratio of the distance traveled by the separated spot to the distance traveled by the solvent. It is a precise value like melting temperature or density, and can be used to identify substances. The RF value can be determined by dividing the distance traveled by the separated spot by the distance traveled by the solvent. The diagram below depicts an example of chromatography known as thin layer. Can you determine which color arrow represents the distance traveled by the separated spot and the distance traveled by the solvent? Alright, so the distance traveled by the separated spot is the green, and the distance traveled by the solvent is the red. And to determine the RF value of this particular solvent, you would use this equation here. So the distance traveled by the separated spot is 6.9. So 6.9 divided by 10 will give you 0.69, and that is the RF value of this particular ink. Separating funnel. A separating funnel is used to separate immiscible liquids that have different densities. Immiscible liquids are liquids which do not mix. For example, oil and water, and here we have it. The oil is lighter or less dense than the water, so it would sit on top of the water, and what would happen is that you would turn the stopcock or the tap, and once you turn it, you will let off the oil, the aqueous layer, which is the water, right? And so you let off the water. If this was water and oil, you let off the water, and then you stop it immediately as soon as you reach this layer. Okay? It's pretty cool. You just have to have quick reflexes. Now, extracting sucrose from sugarcane. This is done on an industrial scale since it is difficult to accomplish in a school lab. Juice is extracted from sugar juice via a shredder and a crusher. Bagasse is removed and calcium hydroxide is added to neutralize the acidity of the juice and remove impurities. The juice is then filtered continuously to remove non-sugar impurities. Next, the juice is made into a syrupy concentrate by using 4 boilers or evaporators. Under vacuum, in a crystallization pan, the syrup is evaporated. A few crystals of sugar are added to encourage crystallization. Molasses is present here. The mixture is then centrifuged to separate raw sucrose from molasses. The white sugar that you receive in boxes is really bleached sugar, because the sugar you get, the crystals that form from sugar cane, is brown. Right, so if you read this over again, I'll go through, you realize that a lot of chemistry is involved in sugar production using sugar cane, and they also use chemistry for sugar production in other types of foods, such as beets, carrots, and that is where the sugar industry in St. Kitts and most of the islands here in the Caribbean went down, we stopped making money from it, because the bigger countries that would have been using our fertile lands to make sugar, they found an alternative, right? Alright, so here you have it. SB makes it easier. See you in the flip side.